Hey guys, thought I'd make a quick video review for your test tomorrow, which will be online, and I'll get to that in a little bit. But first off, just wanted to say that I hope everybody's staying safe. And number one, most important thing is to, take care of yourself and your family, and then everything else can come after that. So as far as physics is concerned, I'll upload things for y'all to do every week and just get them done in a timely manner when I give y'all deadlines and stuff, but worry about your family first. So it's kind of a crazy world we're living in right now. All right, so your test tomorrow is over light and color, what we have been doing the past month. It's going to be on Go Formative. You've probably used that before. Let me make this smaller. You've probably used that before in maybe other classes. I don't know if we've used it in my class, but it'll be on there, and there'll be roughly 25 multiple choice questions, some short answers, and I'd like for you to put them in your own words. I will be checking to make sure you're not copying off the internet, things like that. So, just try to answer to the best of your ability. And then there'll be some math on there. Now you can show your work on Go Formative. It'll have an option where you can upload a photo of your work. So I'll have instructions for that tomorrow as well. And I'll give you guys a couple of days to get this done. I'm not sure what the deadline is yet. I might make it like Friday, or I might make it Monday. I don't know. But you'll definitely have a couple of days to get it done, okay? But I don't want you to wait too long because we do have more material to cover. So, and that I plan on, posting the next material next week. So make sure you don't take too long on that, okay? So again, instructions for Go Formative and how to log in and all that good stuff will be uploaded tomorrow, and you'll have a couple of days to do your test, okay? All right, so quick review. Light, electromagnetic spectrum. Remember, we started with this a while ago now. And the electromagnetic spectrum is all of the forms of light. So every single one of these, gamma ray, X-ray, ultraviolet, visible, infrared, microwave, radio wave, they're all light. Now on your quiz, a lot of you guys got the question wrong about if a radio wave and I can't remember what the other one was, ultraviolet or X-ray, were transmitted to the planet, to a planet at the same time, which one would get there first? They all travel, they're all light, so they're all going to travel at the same speed of light, which is 3 times 8 times 10 to the 8th meters per second. So if an X-ray and a microwave or radio wave are leaving a star and coming to Earth, and they leave at the exact same time, they're both going to get there at the same time because they travel at the same speed. Now, X-rays obviously have more, let me see if I can use this. X-rays are going to have much more energy than a radio wave or a microwave because they do have a higher frequency. So if you see right here, shorter wavelength, higher frequency, and higher energy. But they're still going to travel at the same speed, okay? Make sure you know the order of these. Make sure you understand this relationship between higher frequency and lower frequency, longer wavelength, shorter wavelength, all that good stuff. You guys should be good with that, okay? Visible spectrum, we've been doing a lot of that. Make sure you, you know the order of the rainbow. I know all of you guys do. And, you might have some unit conversion, which you guys should be pretty comfortable with now. Yes, you will be given this. Not to mention you'll be taking your test on the internet. So I know you'll be able to look up unit conversions and formulas and things like that, but I will be posting the ones that you've been more comfortable with and you've seen in my class, okay? Make sure you know white light is comprised of all sorts of light, or of all the colors. Remember, there's just 3 primary colors of light, which are red, green, and blue. And then you get all of the other ones by different shades of those. Okay, you do need to know this frequency and be able to calculate. This is the same formula from last unit. Velocity over wavelength is equal to frequency. Velocity is going to be the speed of light, 3 times 10 to the 8th meters per second. All right, make sure you know how to do, quick little unit conversions. If I were to give you a wavelength of light in nanometers. Make sure you know how to convert that to meters, which I can show you really quick on this, which my handwriting is probably going to be terrible, but just make do with me. So let's say we have this, which is 589, oh Lord, 89 nanometers, okay, and we're going to convert it to meters really quick. So, oh my gosh. I will try to, if y'all have any options or any ideas on how to make digital writing a little bit easier, let me know, email me. So if we're converting nanometers to meters, you would do something like this, 589 nanometers to 1 meter, and you are going to divide by 1 times 10 to the 9th nanometers, okay? So you would divide, and that would give you meters. That should be 5.89 times 10 to the -7th. Ooh, meters. Okay, it doesn't look too bad. All right. Okay, properties of light. Make sure you know. What are we doing? Oops. Back. There we go. Properties of light. Okay, so make sure you know, wave-like properties, particle-like properties, the fact that it can be polarized. So that's all really summed up into the ray model, the wave model, and the particle model. Okay, ray model, light goes in a straight direction, spreads out in all directions. Polarization, y'all played with that in my class a couple weeks ago. Polarized sunglasses, they take light that's kind of going in all different directions and they filter it into where it's just going in one direction. And if you remember with those filters, when you had them both lined up to where they were like kind of 90 degrees to one another, then they blocked out all light. So that kind of shows how light can be filtered. Okay, so make sure you know that. We skipped that. Wave model. Diffraction showed this. So our, single and double split experiment. Hey guys, sorry about that. My battery on my computer died. Okay, we left off here. So make sure you know that, diffraction is different from refraction and reflection. We went over that a bunch, but diffraction is when light bends around an opening it goes through, bends around an opening, versus refraction is when light goes through a medium, so from air to water, and it bends, but it still goes through, and it just bends as it goes through that medium. So diffraction and refraction both have to deal with bending, but it's, one is staying in, diffraction is staying in the same medium, and refraction is it's going from one medium to another and bends as it does that. So think about the pencil in the water. Okay, so as you put a pencil in water, it looks like it's bending, but we know it's not. That's just the light that is refracting. Same with prisms. And then reflection is it bounces off, okay? Can't go through. So light can bend like water. I told y'all about Thomas Young. Interference of waves, that's how we get this type of diffraction pattern. If you shine light through a, monochromatic light through a very tiny slit, or a double slit is what all the math that we have later on, the last thing that we covered, because of that interference, because it's bending around, the monochromatic light is bending through a very tiny hole. And around that, it creates a certain pattern, which shows that light does act like a wave. So make sure you know about the double slit experiment. And then the particle model just shows that there is a certain amount of energy. This formula has to deal with the particle model, that, light is made up of quantized little particles called photons, and they can manipulate elements into, releasing different wavelengths of light. So if you were to energize a atom of hydrogen, that the light coming in and hitting the different electrons will excite the electrons into different orbits, causing it to release particles of light as well. So make sure you understand those. Make sure you know how to calculate the energy of a photon. We did a bunch of this. Okay, you'll get this formula. Obviously, you have to use Planck's constant. Remember that the tricky part of these problems are, the crazy high, or the crazy small numbers and the exponents. So just put everything into parentheses when you are plugging that into your calculator. All right. Okay. Like to the negative 12th, things like that. Okay. All right. I don't think I have any of this conversion on the test. So, but if I do, 1 joule is equal to that. Again, you did that in that color packet of electron admissions lab that we did, where in the front of it looked like this, although I took them up. So I'm sorry you don't have those, guys. But I'm trying to put a grade in for those, okay? Alrighty, Doppler effect, make sure you know Doppler effect of light. So red shift, it's going away from you. Blue shift, it's coming towards you. Now again, what that means is that as something is moving and emitting light, if it's moving towards you, whatever type of signature it has, so if this star is made up of hydrogen, a certain amount of hydrogen or helium, then it will have a certain signature, and if it's moving towards us, then that blue shift means all of these little atomic emission spectra lines will be shifted slightly over to the blue side, to the higher frequency side. Okay, and that tells us that it's coming towards us. Also tells us what the star is made out of. Versus a red shift, if the star is moving away from us, we still know what it's made out of, but instead of, falling at 656, 486, 434, everything's going to be shifted slightly to the red side, so 637. And it will be longer wavelengths, so your wavelengths would go towards the red end of the spectrum, telling you that it is moving away. Seeing light and color. A lot of you guys struggled with this on the quiz with using this wheel. So knowing if you were to put a yellow object underneath a red light, what it would look like. So you guys, some of y'all, it seemed like you either knew it or you didn't know it, okay? So I'm going to go over this a little bit, but make sure that you know, let me just take my face off for a second. Make sure that you know with light, the primary colors are red, green, and blue, and then secondary is magenta, yellow, and cyan, okay? And yes, you'll need to know what different colors of objects look like under different colors of lights. Make sure you know white reflects all colors, black absorbs all colors. It is the absence of light, all right? And then subtractive color, or pigments are the complete opposite. So pigments, when you add them all up together, they actually subtract up light. They subtract out light. So, we've all experienced this when we painted. You add too many colors together and it starts to turn brown, and then it eventually would turn black, okay? Because it's subtracting out all of the colors. And they're flipped. So our primary colors for pigments or paints are magenta, cyan, and yellow. And if you've ever looked at a printer cartridge, like a colored printer cartridge, and if you don't have one at home that you can take out and look at, maybe Google it online, there's actually only 3 colors that are on those printer cartridges. It's magenta, cyan, and yellow, and it really is like these colors because you add those different colors together in different percentages, and you can create green or blue or red or orange or turquoise or whatever it is that you're printing out. So it's pretty interesting if you were to find that printer cartridge. Let me see if I can see printer cartridge colors. Let's see if it's in there. See, look, even just right here, you have cyan, yellow, and pink right there. Or cyan, yellow, and magenta. See, again, cyan, magenta, yellow. Ink refills. Okay. Here we go. This is like what I buy for my printer. Tricolor, cyan, magenta, yellow for paint. So it's pretty cool. All right. Okay. Now, color that you see is because of what's being reflected. So if you see cyan, that means what makes up cyan is blue and green. Now we switched back to light. I was talking about pigment. Now I'm switching back to light because that's primarily what's on your test is the light part. I might ask a little bit about pigments, but you can be definitely sure that I'm going to ask about, what does a red apple look like under yellow light or something like that, okay? So again, cyan. If it's cyan, that means it is emitting or reflecting blue and green. Both blue and green cannot be taken up by that object. And so they're reflected. It bounces off, bounces into your eyeballs. Your eyeballs perceive blue and green together as cyan. Now, only other primary color left is red, so that means it's absorbing any red. Okay? If something is red, it is reflecting red and absorbing the other two. Okay, so notice there's only 3 colors, red, green, and blue, that we're talking about here. And then you get all the other ones for mixing them. So this is the type of stuff that you need to know. Now, a red apple in green light. Let's do that one. Let me show you how I do that real quick. Okay, so if it's a red apple, that means it is red in white light. So first off, the properties of, let me be able to draw something. Okay, so first off, properties of a red apple. Okay, if it's red, that means it reflects red and it absorbs, use all my different colors, it absorbs blue. I'm really sorry if you're colorblind. So I'm going to do words too. Absorbs blue and green, okay? White light, again, is made up of red, blue, and green. Just because that property the property of that apple reflecting green and taking in and absorbing blue or reflecting red and absorbing blue and green does not change if you take it out of the white light, okay? So I know that this is black, but I'm going to say white light. So white light we send towards the red apple, reflects red, absorbs blue and green, okay? So white light is made up of red, blue, and if this is redundant, if you understand this, you got all the questions right on your quiz, oh gosh, blue, then just skip forward like 2 minutes. Blue and green. Okay, so send white light, blue, green, stay, red, reflects. Okay, so let's take our red apple out of white light and we're gonna put it under, green light. So now I've got a red apple and I'm going to give it just green light. So when I send green light, I use my key up here to see what I'd already done under white light. The green does what? The green gets absorbed, it stays. Okay? So then that means what is reflected? Is anything reflected? No, nothing's reflected. If I'm only sending green light, and we already established that green stays, then nothing's reflected. And then the absence of light, so if nothing is reflected, nothing's coming towards your eyeballs, then it's going to be black. It will appear black. Okay? All right, now if we were to do, what was the next one? A red apple under yellow light. Okay, so a red apple under yellow light. So we've got our red apple. We're gonna put it under yellow light, yellow, okay? Yellow is the combination, it's a secondary color. So it's the combination of what 2 colors? Red and green. So yellow, when we send yellow light, we're actually sending red and we're sending green. What happens to the red? It's reflected. Red does not stay, okay? And then what happens to the green? Green gets absorbed. It stays here, does not get reflected. So a red apple underneath a yellow light would look red. All right, let's do one more. What about our red apple under, let's do cyan, a cyan light. So cyan, okay? We're sending cyan. Cyan is a mixture of two colors. It's a mixture of blue and green. So we're going to send blue. I'm getting better at this, guys. And we're going to send green. Okay, what happens to the blue? It stays. So does the green. It does not get reflected. So green stays. Blue stays. And we're not sending red, so nothing's being reflected. So nothing's being reflected. Nothing goes to our eyeballs. Black. So if you notice, for a primary color, if the object is a primary color like red or blue or green, your answers are either going to be black or red. Now, if they're a primary color or a secondary color like yellow, then your answers could be either the two things that make up that color, or it could be black as well, okay? All right, let me turn that off. I'm back. Okay. All right, so make sure you know how to do that. And then the last thing that would be on your test is this diffraction math. So goes a little bit more into detail for diffraction, what you guys have already, we already talked about previously when we were talking about just properties of light. And I will post, I haven't done it yet, but I will post onto Google Classroom today the blank copy of these notes, like the work to the question or to the math problems that we had gone over this past week on Thursday, okay? So, two formulas that you need to know how to use is this first one. Now, in all of this math is to show, like, okay, if we were to send light through a double slit diffractor, which all these problems are going to have to deal with a double slit diffractor, and you get a certain pattern over here that can tell us about the wavelength of light, how far away the screen was from where the light is going through, how far away the slits are, okay? What kind of pattern we're going to get. So the first formula is this d sine theta is equal to m wavelength. D is the spacing between the slits, so that would be this right here. Spacing between the slits. That's in meters. M is the number of fringe. So the first fringe would be this one. Right here it says N. I just use M. So fringe, okay? First, second, third. If it's 10th fringe, then that number is going to be 10. If it's 5th fringe, then that number is going to be 5. Then that's wavelength. And then this is the angle in which the light actually bends around that object. So how much that light bends will determine what pattern you get. If it's bending a lot, you're going to get a really spread out pattern. If it's not bending a lot, if it's teeny tiny, just bending a little bit, then you're going to get a very close pattern, diffraction pattern. Okay, we went over these in class. I will post the work to these though, if you're curious as to how to solve these and the answer as well. And then the second formula you need to know is this one, y is equal to L tan theta, where y is the distance between the fringe to the center fringe. So this is a different distance. Y is talking about the actual distance between these guys, your pattern. D, as in dog, is talking about this. All right, let me make something that shows all of these. Hold on, copy, paste. All right. Okay, so D has to deal with, what color should I use? Let's use this one. This is D. I'm going to use a better color. Okay, this is little d in meters. How far apart these are, okay? That's d. All right, we already established what n is. Y is, this is y. Y is the distance between your fringes, or technically it's the, it would be the distance between, to that. So that's y, all right? Switch colors one more time. L, big L, would be the distance between the screen, where your pattern pops up, to where the light was going through. So that would be L. All right, different distances here. They're all in meters. D is the distance between your two slits. L is the distance between this to the pattern, the screen, and then Y is the distance between your two patterns here. Okay? All right. Again, I will post, we went over these in class on Thursday. I know some of y'all were not in class on Thursday, so this past Thursday, so please look at the work posted in there on Google Classroom when I post it today. You know, try to practice, get the right answer. Email me if you have any questions. Remember, I still only work part-time, so I'm really trying to stick to that too, and only answering emails in the, you know, before 12 o'clock. I'm sorry guys, but that's how I gotta stay sane in this time. So you know, occasionally I will, like if my daughter's sleeping or napping in the afternoon, I will check my email in the afternoon every now and then, but I'm trying to keep it to the morning, okay? So if I don't respond until like the next morning, that's why. All right. Now again, your test tomorrow, you will have a couple days. It'll be on Go Formative. I'll post information about that tomorrow. You can expect 25 multiple choice questions, a couple of short answer questions where I do expect written responses, or, you know, typed out responses in your own words. Now, if I find that you have copied and pasted from a friend, or you've copied and pasted from the internet, you will get 0 credit for those answers. Okay, 0 credit. So put them in your own words, all right? And yeah, just do your best on that. And then, of course, the free response math now on Go Formative, it has the ability for me to ask for you to upload a picture of your actual work, okay? Again, with that, if I notice that you have the exact same picture as somebody else's work who has posted it, that's not okay, and both of you guys will get a 0 on that, okay? So you have to do it in your own handwriting, all right? And, you know, I'm going to try my best to make sure everybody's different, but I also know that we are all working remotely, so, you know, best of my ability, I will try to be fair in grading these and assigning you guys assignments and things, and just try to do your best, okay? We're all kind of in a crazy world right now, and, you know, I still want you to learn physics and do well, and I want your tests to reflect your actual grade and your understanding, so I can help you best I can and assign different resources, all right? So anyways, stay safe, guys. Be, you know, take care of yourself, take care of your family first, and this test will be no sweat, all right? Well, let me know if you have any questions. Email me. Bye, guys.